Here's our second video identifying chiral centers in larger organic molecules in different representations. So here I have a couple of commonly prominently used drugs. Efavirenz is used in mixtures to treat various infectious diseases, including some viral diseases. Dimethylfumarate is used in treating some neurological and mental disorders. And these structures are taken from this website 3dchem.com by Carl Harrison. It has lots of great molecules and great information. It's a fun website to just browse and click around in. So here is a ball and stick three-dimensional representation. And it can be a little hard to see all the chirality. So we're going to translate this into a line angle structure. I'm going to start up here with this ring. This ring looks pretty flat, and each carbon only has 3 things attached. So that tells me a couple of things. Well, it tells me that there are double bonds and that this is a benzene ring. So I've drawn the benzene ring. I've got a green molecule coming off. That typically represents a chlorine. So I'm going to put a chlorine there. Off to the right, we've got a nitrogen, and then a carbon with just 3 things attached. The oxygen there doesn't appear to have a hydrogen on it. So I'm going to put the nitrogen in. And go to the oxygen. And since that oxygen only appears to have 1 bond, that's going to be a double bond. I've got another oxygen, a carbon, so I've got another ring here. This carbon down at the bottom of it has 4 things attached. So it doesn't have any double bonds. It has a carbon with 3 green molecules, that I'm going to draw as chlorine because they're larger than the carbon. If they were fluorine, they should be smaller than the carbon, but I'm not entirely certain. I'd have to go back and look at it. We've got another carbon coming off this way. Okay, so we know that this carbon here does not have any double bonds. And this carbon here has a double bond there, so those are single. And this oxygen has both the bonds it needs. And this nitrogen has all 3 of the bonds it needs. So that's an NH group. We could draw in lone pairs. The nitrogen's going to have a lone pair. This oxygen here will have 2. This oxygen will have 2 as well. Okay, we're coming away from the ring here. Here's a carbon, carbon. No hydrogen attached to either of those carbons. And it looks like it's in a straight line. That's going to be an alkyne, a triple bond, to give us that straight line all the way across those 4 carbons. It's also very short there, shorter than the single bonds. Okay, and then this carbon here, 1 bond towards the alkyne, 1 to hydrogen, and 2 into this propyl cyclopropane ring, cyclopropyl ring. All right, that's our molecule. The hydrogen in this case is coming up, and these two, whoops, I did it the wrong way. Hydrogen coming up should be a wedge, and then if I were to draw these properly, these two going back would be dashed, both going back into the page. So let's identify chiral centers. There are a whole bunch we can rule out. Anything on a benzene ring, anything else with a double bond or a triple bond can be ruled out. Anything out on an edge, anything with lone pairs. So we can rule out just about everything. In this ring, these two on the corners have 2 hydrogen each. So we can rule those out. So we've only got a few possibilities. I'm going to circle those possibilities very faintly with this pink. We've narrowed it down to 2 possibilities. Let's count the different groups attached. Okay, the alkyne going this way, the oxygen towards the benzene ring is the 3rd, and towards this trichloromethyl group is the 4th. So yes, that's a chiral center. Go to this one here. It's got the alkyl group going one way, the hydrogen going one way, and then 2 different directions around this symmetrical cyclopropyl ring. So it is not a chiral center. This one is achiral. So there's only one chiral center on this whole complex molecule. Let's go over to dimethylfumarate. Ones we can rule out. Do you remember why we can rule that one out? 3 H's, double bond, double bond, double bond, double bond, 3 H's. There are 0 chiral centers on this dimethylfumarate molecule.